This is part 2 of sections 5.1 and 5.2. We have been working with our power rules. We want to simplify here. 8s to the 4th power times t times 3s to the 3rd power t to the 5th power. Now, you know that we say squared for 2nd power and cubed for 3rd power. That both of those terms come from the rules for area of a square and volume of a cube. That's where we get those terms from. What we're going to do is we're going to multiply the pieces that we can. We are allowed, of course, to multiply 8 times 3, which will give me the 24. Okay, that part's done. Now I get to multiply these s's together, and since they have the same base, I add those exponents. So this is going to be s to the 4 plus 3, which is s to the 7th power. Okay, now we multiply our t's. I have t times t to the 5th. That's t to the 1st power. Okay, if it doesn't have an exponent on it, it's an understood 1st power. So I am adding t to the 1st, so 1 plus 5, I get t to the 6th power. Okay, and I was using property 1 through all of that. Because it was all multiplication, I could rearrange things however I needed to. Okay, so let's look at 14 to the 0 power. I have my property that deals with the 0 power is number 2. So I'm going to use property number 2. And it says a number or a variable raised to the 0 power is 1. So this is 1. That's it. You don't have to think about it. If you can use your calculator as well, 14 raised to the 0 power is 1. It helps. Okay. Now let's look at these two. Okay. I have negative 10 to the 0 power with the negative 10 in parentheses, and I have negative 10 to the 0 power without the parentheses. This is something you have to get in your head. Those parentheses, especially when you're dealing with negative numbers, matter. Okay. Your calculator can help you tell the difference between the two, but you're the one who has to remember that there is a difference, and you have to remember to use your calculator. Okay? This one means the number negative 10 raised to the 0 power. So that whole number is being raised to the 0 power, so your answer is 1 by the second property. This one, however, is the number 10 to the 0, and then you make it negative. Now, don't ask me why this is the case. It is notation. Somebody made this up at one point. It stuck, and we're stuck with it. Okay? So this answer is negative 1. Let me show you on the calculator. If I open parentheses and put the negative 10 in there, and then raise that to the 0 power, you can see that I get 1. But if I enter straight negative 10 raised to the 0 power, I get negative 1. So there is a difference. You are the one who's going to have to remember to check it. Okay? Okay, so let's look at this one. This is negative 8 to the 0, and that's a negative, and it does not have parentheses around it. So this is going to be like this one, minus k to the 0. Okay? So in this case, we need to simplify those exponents because exponents come before subtraction in the order of operations. We'll simplify those exponents, and then we will do the subtraction. Okay, so first I have negative 8 to the 0. That's almost exactly the same as this, right? Without the parentheses, you get negative 1. And I'm using property 2 for this step. Okay, minus k to the 0 power. Well, k to the 0 power is 1. You could let this confuse you if you you could, but this minus sign is right here, and that looks funny, so let me write my ones like this. I have negative 1 minus 1, so your answer is negative 2. This negative, you can think of it as a negative or you can think of it as a subtraction. Don't use it both ways. If I wrote it down as a subtraction and then I calculated this negative like I did up here, I would have ended up with -1 plus 1 to get 0. So this is either a subtraction or it is a negative. It can't really be both when it comes to the calculations. I hope that made sense. I'm not even sure that made sense. Okay, so let's go on to the next page. And I'll trust you guys to contact me if that did not make sense. Okay, so let's simplify 12 to the -1 power. Where do I deal with negative powers? The first place I deal with them is right here. I have -12 raised to the -1 power. So my n is a 1 and a is 12. This, by property number 3, is 1 over 12 to the first power, because your exponent becomes positive when you move it down to the bottom. And we don't normally write the first power. So your answer will be 1/12, and that uses property number 3. Okay, so let's look at this one. This type of problem, I see a lot of mistakes on. And that's because people, let me just show you what you don't do. People see the negative exponent, they remember that they need to move it to the bottom, and so they write down 1 over 5t to the third power. The reason this is not correct is because there is an understood first power on that 5. The exponent on the 5 is a positive number. It's not going to move. Right now, you can think of this as over 1. Okay? I am going to be using property number 3. But property 3 only applies to the t. It does not apply to the 5. The 5 is going to stay on the top. The t cubed moves to the bottom. Okay. So let's look at 3 to the -3 and 2 to the -2. The property I have that looks like this is, first of all, I noticed that they have different bases. And a lot of our properties require that they do have the same base. It makes it a little bit easier to find the one you want. The one I want is right here. I have different bases and negative exponents, and they both move. So what's in the bottom, move to the top. What's in the top, move to the bottom. So this is property number 6. And it becomes 2 squared over 3 cubed. Now, this one is one that they might want you to multiply out because you can generally do these in your head. This means 2 times 2, so that's 4. This is 3 times 3, which is 9, times 3 again is 27. 4 over 27 is the answer that they would be looking for. Common mistake. 3 to the third power does not equal 9. Just a very common mistake. Everybody knows better than to do that, but we do it anyway. And I'm including myself in that. Okay? So let's do 5 over 4 raised to the -2. You have options here, and that's something you're going to have to get comfortable with. When you're simplifying using these properties, you often will see several legitimate first steps. Don't worry at this point about picking the best one or the quickest one. If you see something to do, you just do it and you'll get the answer. So I'm also saying that because you might be choosing different paths than I do in these videos, that does not necessarily mean that you're wrong. Okay? So if I have a fraction raised to a power, here I have a fraction raised to a power, here I have a fraction raised to a power. Okay? Either of these work. You will also probably find that you are combining steps as you work more and more of these problems. That's to be expected. Am I going to, do I expect you to be able to do it in your head at this point? No, I expect that you will probably start combining steps. Just because I don't have a lot of examples where I can use number 11 very well, I'm going to use property 11 here. And that's simply a choice as an instructor. So I'm going to use property 11. Now what property 11 tells us to do is you flip what is inside, no matter what this is. Later on, these can be pretty complicated things. These can have exponents on them. These can even have negative exponents on them. property 11, we just flip what's inside. It does not matter what is there. So this is the same thing as 4 over 5. Now you change that to a positive exponent, squared. Okay, now I still need to simplify this. To be simplified in general, you don't want, I should write this down, because that's going to be what you're being asked to do. You're going to simplify these. That means no parentheses left, no negative exponents, and no repeated bases. This is almost always the case. You can almost always combine things if they have the same base using one method or another. Okay, so right now we have a fraction inside parentheses, and we're not simplified if we have parentheses. So what we want to do is we want to find a property that allows us to deal with a fraction raised to a power. So now I'm going to use property number 9. And property 9 says that you take that outer exponent and you apply it to both the top and the bottom. So this is 4 squared over 5 squared. And this is definitely one they would expect you to be able to do in your head. 4 times 4 is 16. 5 times 5 is 25. And that would be your answer.